Dude, why are you messing up? I don't want to take a haircut.
What's the
Yeah, you can dress like a farmer.
No.
I don't actually.
I didn't.
That's cultural appropriation.
Okay, I didn't really process that like a lettuce theme also kind of tied into a farmer theme, and so last night kind of surprised me. I was like, oh my god, Spencer and Calvin make me.
That's hilarious. Wait, what'd you say?
Spencer and Calvin are making me hate some of this.
I don't
They were dressed as farmers.
Against farmers.
I just like
Everything.
yes.
I'm dressing as a farmer just for you tomorrow.
Do I even have any classes in the
Craig, I don't know. Remember when my dad like cut off flannel things? Yes, you should.
Okay, here we go. Asymptotes. What is the limit as x approaches -3 from the left on this first one? As we're approaching -3 from the left. What is the limit? It goes down forever. So the limit as x approaches -3 from the left is -infinity because it goes down forever. Okay? What about the limit? Move it up just a little bit. The limit as x approaches -3 from the right.
Infinity.
We'll say that that's infinity. What about the limit as x approaches -1 from the left? Infinity. And the limit as x approaches -1 from the right?
Negative infinity.
-infinity. Okay? What about looking at this? What's the limit as x approaches infinity? What would the limit be as x approaches infinity there? It would equal 2 because it's getting closer and closer to an x or y value of 2. Okay? So, for this one, what's the limit as x approaches -3 from the left? Infinity. Limit as x approaches -3 from the right? -infinity. And the same with as we approach 1 from the left, infinity. As we approach 1 from the right, -infinity. Okay? Now, when you get to this, I plain and simple have to graph them because I have too tough of a time trying to work them out in my brain of what that's going to look like without graphing it. Okay? So I grab my graphing calculator. He's at the bottom of my list. And there he is. So if I go y equals, clear out what's in there, and go x divided by, and then I have to go parentheses if there's complicated items either in the numerator or denominator, you have to put them in parentheses. So it's not just dividing the first thing, that's dividing everything. So it's 10. And then to put in sine squared, it's the sine of x plus 1. And then you have to square. I have to go back here, sorry. So it's 10. I have to go throw in a parenthesis, and then I have to go sine, and then x plus 1 parenthesis, and I have to close a parenthesis, and then square that, and then go parenthesis again. And let's graph that, see what that looks like. Ooh. Interesting. So, as we approach -1, okay? As we approach -1, so if we go zoom a little bit, And we go zoom in, I suppose, at -1 or close to -1. As we go towards -1 from both the left and the right, where is it going? Looks like it hits an asymptote. They're both going down, so they both hit -infinity. So that would be choice D. Okay? A natural log squared is always going to be, if we put a number in here and square it, it's always going to be positive, right? Especially at 2. 2 minus 1. If we put in a 2 here, 2 minus 1 is 1. And we're taking the natural log of 1. If we square it, that's going to always be positive, right? No matter what. So as we're approaching 2, if we put in a 2 here, that's going to make the top negative, whether we're approaching it from the left or the right, correct? So let's just look at the graph just to be certain. So if we go y equals, clear out what's there, -x divided by parentheses, the natural log of x minus 1. Oh, need one more set of parentheses. Yes, I do. Parentheses, ln of x minus 1, parenthesis, and then that takes care of that. And then I go parenthesis, squared, parenthesis. I think that's what I need to do. Graph. And then I have to go zoom 6 to get it back to a 10 by 10 window. Okay. What's happening as we go towards 2 from either way? It's going towards -infinity because no matter what we do, this is negative. Okay. So it's -infinity from both sides. Okay. All right. The next one. Two over x minus 3 squared. We graph that. It looks like it's going towards positive infinity from both sides. Okay? All right. Horizontal asymptotes. What's the limit as x approaches -infinity on this one? What's the limit as x approaches -infinity? It looks to be 0. What's the limit as x approaches infinity? -1. Okay? So you can do those. Now these are the easiest ones if you pay attention, Ms. Strong. So if the numerator of the highest power on the top in the numerator, if the exponent of the highest power in the numerator is higher than the exponent of the highest power in the denominator, and you're going towards infinity or -infinity, the limit is unbounded. If the top is higher than the bottom for the highest powers of each, it's unbounded. If they are equal, if the highest power of each are equal, then you use the coefficients of the highest power. What's -6 over 1? -6. If the power on the denominator is higher than the power in the numerator, then the limit is 0 because it'll go towards 0. It'll go towards the x-axis. Okay? Whether it goes towards infinity or -infinity. Okay? Then we'll have problems with square roots. Well, what's the square root of 16x to the fourth? What's the square root of 16x to the fourth? 4x squared. Okay. And the other part we don't even worry about because we're just worried about the highest powers of each. Okay. Since these are the same power, what's the limit? 5/4. 5/4. And since it's an even power, if we're going towards negative infinity, that just makes it positive. Okay? But if we have an odd power and we're going towards negative infinity, then it changes the sign. So what's the square root of 9x squared? 3x over 2x. So the highest powers are the same, so it would be the coefficients. And because we're going towards negative infinity, it's a negative 3/2 because we're to the first power. If we're to the first power, the third power, the fifth power, it'd be negative. If we'd be at an even power, it'd be positive. Okay? That's basically what we're doing before lunch.